Hello, math friends. Welcome to A Squared Math and Stuff. This example focuses on a set of system of equations, and we're going to solve this system using Gauss-Jordan elimination. Before we get into this, there's a couple things I want to go over with you really quick. The first thing is just to remind you what reduced row echelon form looks like. So that's when we have this diagonal of ones and we have the zeros below this diagonal. So we have this triangle of zeros below, and we also have a triangle of zeros above that. And once we get this reduced down to this reduced row echelon form, to the right side of this line, this is going to show us what the values for our x, y, and z are. So this will be what x equals. This row 2 will be what our y equals, and row 3 is what our z equals. The next thing I wanted to go over is the order that I recommend you solve this 3 by 3 matrix in. A lot of people like to solve to get this 1 in this position here because we want a 1 here. I don't start there because many times we end up working with fractions throughout this entire 3 by 3 matrix. Fractions aren't always fun to work with. So if we actually work with row 2, column 1 first, and we turn that into a 0, we tend to have nicer numbers. So I recommend that we start row 2, column 1. The next position we work with is row 3, column 1, and we complete row 3. So we work on this first. This would be, or this first, second, our third number we work with, the fourth number. Then we jump to row 2, column 2, and we make that a 1. Then we make this our 0. And then we work our way up and backwards across row 1. So this would be the 7th, the 8th, and the 9th thing that we do. The only way that we wouldn't necessarily make this our last value is if we can swap two equations. And that's what this example that I have here starts with. So the example that we're going to work with here, let's make our augmented matrix for this. And I already have that set up. So again, the augmented matrix turns this system of equations into a matrix, and we have all of our leading coefficients and what the equations equal. So what I'm going to do to start is I see that I have a 1 here in this row 2, column 1 position, and I'm actually going to swap row 2 and row 1. So my next matrix, so I'm actually going to swap row 2 and row 1, and our next matrix looks like this. We haven't done anything with row 3, so I'm going to rewrite the values for row 3, and I'm going to indicate that I'm swapping 2 rows, and we do that with the little curved lines with the double arrowhead. We're going to write row 2 up here because this says this was row 2, but we're making it row 1. We're going to write row 1 here because we moved row 1 down to row 2. Our new values are then row 2 moved to row 1, so we have row 1, 1, -1, and then 5. And row 1 came down to row 2. Those values are 2, 1, 3, and 2. So now we have that 1 and that leading coefficient for row 1, column 1. So I don't need to do anything with that anymore. But now what I want to do is I want to focus on this 2, and I want to make that a 0. I can make this a 0 by multiplying row 1 by a -2 and then adding that to row 2. So let me write that down for you. I said we're going to multiply row 1 by a -2. So -2 times row 1, and then we add it to row 2. We're not doing anything to row 1 or row 3, so let's just rewrite those. For -1, 2, and they equal 5 and -1. In my last video, I guided you with the thinking process of how to solve these. So I'll do this on this first matrix, but after that, we're going to do the rest of the calculations in our head. So I'm doing -2 times row 1. So -2 times row 1 gives us a -2 here, and then another -2. -2 times a -1 gives us +2, and then -2 times 5 gives us a negative 10. Now I'm going to look at adding the negative 2 and the 2. Those give us a 0. So we'll write 0 right there. Negative 2 plus 1 gives us a negative 1. Positive 2 plus 3 gives us 5. And then finally, negative 10 plus 2 gives us a negative 8. So we have the 0 here in that position that I said we should get a 0 in first. So now we're going to work with this 4. We want to make this 4 a 0. So that's the second number we're going to work with. So in order to make that a 0, we can take negative 4 times row 1, and we will add it to row 3. So negative 4 times row 1 plus row 3. And you'll notice too that I always write the operations that we are working with next to the row that we are changing. And I also write the row that is changing second in this addition equation. So we're not changing row 1 or row 2, so rewrite those. 0, negative 1, 5, negative 8. And we're taking negative 4 times row 1, which was a negative 4, add it to row 3, so that makes this a 0. Negative 4 times this one, add it to negative 1, so we end up with a negative 5. And then a negative 4 times negative 1 gives us positive 4, plus 2 gives us 6. And then finally, negative 4 times 5 gives us negative 20, minus 1 gives us negative 21. So we've got the two zeros. Now we're going to work on this place where the negative 5 is, and we're going to make that a 0. This time we're actually going to manipulate row 2 and add it to row 3, because if I manipulate row 1 again, that will make this a number, and I'm adding a number to 0. So I've then gone backwards because I lost my 0. Remember, in the reduced row echelon form, we have a 0 here. So looking at just rows 2 and 3, if I take row 2 and multiply it by negative 5, I'll get a positive 5, and if I add the positive 5 to 5, I get 0. That's what we're looking to do. We are going to take a negative 5 times row 2 plus row 3, and we're changing row 3. We're not doing anything to row 1 or 2, so let's rewrite those. 0, negative 1, 5, negative 8. Our new row 3 becomes negative 5 times 0 is 0. Negative 5 times the negative 1 is positive 5, plus negative 5 gives us 0. Negative 5 times 5 gives us negative 25. Negative 25 plus 6 gives us negative 19. And then finally, negative 5 times a negative 8 is positive 40. Positive 40 minus 21 gives us a positive 19. Now we need to get a 1 in row 3, column 3. So all we have to do is multiply row 3 by a negative 1 over 19, because you can't divide in matrices, but we can multiply by a fraction. Again, we are not changing row 1 or 2, so let's copy those down. And then finally, we have 0, 0. Negative 1 over 19 times 19 gives us positive 1. And then a negative 1 over 19 times 19 gives us a negative 1. We have just solved for z. Z is equal to negative 1. And we are now in row echelon form because we have this bottom. Oh, we're not quite there yet. Hold on. We have to get rid of this negative in front of this 1. Let's move you up here so you can see more. We have to get a positive 1 in row 2, column 2, and we can do that by multiplying row 2 by a -1. Rewrite those rows that we are not changing at all. And now we have a matrix that looks like this with our blank row 2. And we're going to multiply row 2 by a -1, so just negative times row 2. We end up with 0, +1, -5, +8. Now we are in row echelon form. We have +1s going down our diagonal, and we have that lower triangle of zeros. Our goal now is to get this to be a 0, because we already made this the +1. Now we want to turn our -5 into a 0. So we can do that. We're going to work with row 3 and then add it to row 2 this time, because now we have zeros here, and 0 times anything is 0. 0 added to anything is the same number that we had. So let's do 5 times row 3 plus row 2, and that will give us our new matrix, and we should have a 0 in the position that we want. Copy down those rows that we are not working with, that we are not changing. And then let's change row 2. So 5 times 0 is 0. 0 plus 0 is 0. 5 times 0 is still 0. 0 plus 1 is 1. Now -5 times 1 plus, now 5 times 1 plus a -5 gives us 0. And then 5 times -1 gives us -5 plus our 8 gives us 3. We have now solved for y. Let's get a 0 in the position where we have a -1. And we can do that by adding row 3 to row 1. Adding row 3 to row 1. So row 3 plus row 1 gives us our new row. Rewrite everything that we have not touched with this manipulation. And our new row 1, 0 plus 1, 0 plus 1, gives us 1 in both of those positions. Now 1 plus -1 gives us 0. -1 plus 5 is 4. We are down to our last row operation, ladies and gentlemen. All we have to do now is get a 0 in this position here. We can do that by adding a negative row 2 to row 1. So again, a negative row 2 plus row 1. Rewrite row 2 and 3 because we are not changing those. Now, negative row 2 plus row 1 gives us a 1, 0, 0. -3 plus 4 gives us a +1. We are now in reduced row echelon form. So this means that we have just solved for x, y, and z. X is going to equal 1. Y is going to equal 3. And z is going to equal -1. You have to write this in coordinate point form. We end up with 1, 3, -1. And ladies and gentlemen, that is your final answer. So what you just did is you just saw how to solve a 3x3 matrix using Gauss-Jordan elimination. We got it all the way down to reduced row echelon form. We got our final answer. If you like what you saw, please hit that subscribe button down below, and I will be chatting with you later. Thank you.